Good morning to everyone. I'm Dr. Sumi MS. The topic of my today's presentation is laser ablation in nanotechnology from Unit 2 Synthesis of Nanomaterials in Nanotechnology. On completion, the students will be able to understand the relevance of laser ablation in nanotechnology and also list down the types of lasers employed in nanotechnology. Laser ablation. Laser ablation is the process of removing a material from a solid or occasionally a liquid surface by irradiating it with a laser beam. And how it is relevant to nanotechnology. It is widely used for synthesizing nanoparticles, thin films, surface patterning, and also nanostructured materials due to its high precision as well as control. Basic principles of laser ablation. The mechanism involves laser beam focuses on the material and the material gets absorbed the energy and it results in rapid heating and sublimation or vaporization process occurs, and as a result plasma formation is resulted, and following that ejection of atoms, ions or clusters of atoms or ions resulting in nanoparticle formation. The key parameters influencing the ablation are the wavelength of the light, either UV or visible or IR, pulse duration, energy density, repetition rate, as well as the ambient environment in the form of vacuum or gas or liquid. Types of lasers used. The laser types may be nanosecond laser, femtosecond laser, which is mainly employed for ultra precise ablation, or excimer lasers, which are UV laser sources. Laser ablation techniques followed in nanotechnology. Pulsed laser ablation in liquids. Here the target material is immersed in liquid and the nanoparticles are formed directly inside the liquid, and this results in clean and chemical free synthesis. Laser ablation in vacuum or gas. These are used for thin film deposition. Example, pulsed laser deposition. Laser induced breakdown spectroscopy. Analytical technique which is using a plasma emission, and this technique can detect and quantify elements at nanoscale range. Applications of these methods in nanotechnology. Nanoparticle synthesis. Metals can be synthesized as nanoparticles in silver, gold, platinum, etc. And also semiconductors like silicon zinc oxide are employed for synthesis, and oxides, titanium dioxide as well as Fe2O3 or some of the oxides being synthesized with this method. Then surface nanostructuring, controlled formation of nanopatterns, as well as they have some applications in biomedical implants as well as sensors. Thin film deposition process. Here high quality thin films are being formed which have applications in electronics, optics as well as sensors. Material modification. Tailoring surface energy, hardness and conductivity improvement in materials. Advantages of laser ablation. In these laser methods, no chemical precursors are used and high purity of the nanoparticles are achieved. Non-contact and highly localized process is being followed, and it is results in scalable and flexible for various materials. Limitations. The laser equipment is quite expensive and lower yield is only obtained when compared with the other chemical methods, and also the process has high complexity in controlling the particle size distribution, and it requires vacuum or controlled environments in certain methods. Recent advances and recent trends in this field are green. They are employed in green nanotechnology, where they use water as the medium for the method PLAL, and hybrid techniques are obtained by combining laser ablation with chemical methods also, and real-time monitoring where in situ analysis of the nanoparticle formation is employed. Laser 3D nanoprinting, this is for advanced device fabrication applications. Safety and precautions. High power lasers require shielding and eye protection, and also proper handling of nanoparticles, which if not may result in inhalation risk. Then safe disposal of the target and the liquid medium being used. Quiz questions on laser ablation in nanotechnology. Define laser ablation. What are the key parameters influencing laser ablation? Write about the laser ablation techniques in nanotechnology. What are the advantages and limitations of laser ablation? Thank you.